This video covers the nanomaterials, in particularly structure, properties and application of fullerenes, carbon nanotubes and graphene. Kindly subscribe my channel, also like the video and share the videos. The first one atom molecule is a fullerene, nanoparticle is a fullerene. The structure of fullerene is like a ball. See here, in the fullerene structure, we may observe the 6-membered ring joined to another 5-membered ring, and the 6-membered as well as a 5-membered ring you may be observed. Okay, and the entire structure that is made up of carbon atom. Only the carbon atom is present. It's the common elements in organic compound. It's known to exist in two allotropic form, that is diamond and graphite. And the third form of carbon called fullerenes that was discovered around 1985. In carbon, we may observe a different types of, in fullerenes, we may observe a different types of fullerenes, that is C60, C70, and even there is a components like C. We observe the compound, the fullerene in C74 form or even C76 form. They are rarely observed. 78 and C80, etc. will observe the fullerene have been prepared and even now it is investigated. The most common is the C60 fullerene called Buckminster fullerene. The most common is the C60 fullerene called Buckminster fullerene or buckyballs. The fullerenes are made by heating of graphite in an electrical arc in the presence of inert gases. So usually helium or argon used as an inert gases. It is just by heating a carbon in an electric furnace in the presence of inert gases like helium or argon. So the electric arc liberates a black powder in the form of a soot. 10% of the soot is made up of C60 and this is extracted by salvation in a small amount using a small amount of toluene. The sooty material formed by the condensation of carbon vapor consists of mainly C60 with a smaller quantity of C70 and traces of fullerenes containing even number of carbon atoms up to 350 or above. So it is prepared by using a graphite heated in an electric arc in the presence of inert gases like helium or argon. Thereby, sooty materials are formed by the condensation of carbon vapor, which consists of C60 with a smaller quantity of C70 and traces of fullerenes containing even number of carbon atoms. The thermostable is C60. The most stable form of fullerene is a C60, mainly containing 60 carbon atom and has a shape like a ball. Okay, then the structure of fullerenes. The fullerene is a nano-sized allotropes of carbon having a cage-like structure. It is having a, you can see here, it's like a cage-like structure. The diameter of the molecule C60 is 1 nanometer. The diameter is 1 nanometer. The diameter of this one is 1 nanometer. And it contains, usually it contains 26 6-membered ring. It contains 26-membered ring and 12 5-membered ring. Okay, it is made up of 26 membered and 12 5-membered ring. 26 membered ring, 1, 2, 3, if you count it in the ball, you can observe 26 membered ring and 12 5-membered ring. And again, the arrangement is 6-membered ring is fused with the 6-membered rings, but the 5-membered ring is always fixed with the 6-membered ring. See here, the 6-membered ring may be fixed with the 6-membered ring, or even it may be fixed with the 5-membered ring. So this is a 6-membered ring. It may fuse with the 5-membered ring as well as fused with the 6-membered ring. But In 5-membered ring, it is always fixed with the 6-membered ring. This type of arrangement is observed in the fullerene. And all the carbon atom here, it is undergo sp2 hybridization. And each carbon atom forms a 3 sigma bond with other carbon atoms aromatic in character. So this carbon atom, if you observe 1, 2, 3 sigma bonds, it consists of a 3 sigma bond and ball shaped with the 60 vertices is formed. And if you observe the single bond distance is 143.5 ppm and the double bonded distance is 138.3 ppm. Single bond 143 and the double bond is 138.3 ppm respectively. At room temperature, the molecule is a solid and face-centered cubic structure with 1.72 gram per cm cube of density. So this is about the structure of fullerenes. Now coming to the properties of fullerenes, the fullerenes are soluble in most of the organic solvents like a benzene, toluene, chloroform, etc. That is non-polar solvent. They show lubricating property. Fullerenes are chemically reactive molecules. They are chemically very active molecule. They have a high electrical conductivity. Almost all fullerenes are high electrical conductivity. Fullerenes are a strong drug absorbent. So it is a strong drug adsorbent. It can absorb a drug component and fullerenes has antiviral properties. So these are the main properties observed under fullerenes. So because of these properties, we can apply this fullerene in the manufacture of some components like even in the drug delivery systems, it can be used. And the properties, it is a black color powder, and other than this, it is a black color powder, and the density is about 1.73 or 1.65 gram per cm cube. Refractive index is very high, and it can be dissolved in most of the solvents like benzene, toluene, even carbon disulfate. The molecules are a semiconductor, conductor, and superconductor under specific condition, or it is highly electrical conductivity. It possesses photochromic effect also observed in the fullerenes. Now, the application of these fullerenes, it is used as an optical filter. In most of the instruments, the fullerene is used as an optical instrument, and it is also used as a hydrogen storage materials in batteries. In batteries, it is used as a hydrogen storage material. It is even used in the drug delivery system. So they are used as an antiviral agent. This is used to provide a unique molecular structure, antioxidant effects, and biologically it is compatible one. Some fullerenes form a conjugated with the proteins and DNA. So it find a wide application in the medicinal field. So it is used as a in the drug delivery system. And even the dry lubricant in coating application, fullerene is used. In electronics, they are used as a molecular switches, diodes, transistor, resistors for lithography, solar cell elements. The another important application observed is a solar cell element, combining fullerenes, nanotubes, and polymers to produce an inexpensive solar cell that can be formed just by painting. So even it is used in the solar cell. And hydrogen storage system, it is used possibly as a fuel cell tank, and even powered by a car. Car can be powered by this fullerene components. The magneto-optical recorder, photoelectronic device. So these fullerenes find an applications. And fullerenes are chemically reactive and can be added to polymers. I already informed. So while manufacturing a solar cell, it is combined with the polymers, so we can get an inexpensive solar panels. So elastomers to create a new copolymer with a specific physical and chemical properties. These are the main applications observed under fullerenes. The next one, nanoscale materials, is CNT, carbon nanotubes. These carbon nanotubes are one-dimensional concave cylinders. Its diameter is in the range of nano range and the length is in the micro range. They are allotropes of graphitic carbon with a cylindrical structure and diameter less than 100 nanometer, and the length can up to few microns. That is, the diameter is in the nano range and the length is in the micro range. So these CNTs are members of fullerenes, and almost structurally it's a similar one. So they comes under the same family. There are two types of CNTs. They are explained on the basis of number of walls present in the CNT. Uh, the CNTs are single sheets of graphene rolled into cylinder. As you can see in the picture, it is a single sheets rolled in the form of a cylinders. Single wall nanotubes, they are formed by rolling up of a single graphite layer. The diameter of single walled carbon nanotubes is 1 to 100 nanometer and length can up to 5 microns. And multi-walled carbon nanotubes, that is this one, multi-walled carbon nanotube, they consist of two or more concentric graphene cylinders with van der Waals force between the adjacent tube. There are, you can observe 1, 2, 3, 4 like different tubes. There exists a van der Waals force of attraction between these tubes, and diameter varies from 30 to 50 nanometer, and the length can again the few microns. On the other hand, there are three unique geometric carbon nanotubes. The three different are referred as a flavors. The flavors may be armchair flavors, zigzag flavor, and the third one, what we called it as a chiral flavor. Here, armchair flavor, it is a cylindrical like components. Here you can observe the carbon graphene structure is like the same way, and in the comparison to zigzag tubes, here you can observe the zigzag tubes. The graphene sheet is turned up to 30 degrees Celsius before rolling up. Perfect termination is an edge consists of the side of the last row of 6 members rings, and this one is a conductor one. And the structure of CNT plays an effective or significant in their electronics, chemical, and physical properties. In the CNT is generally produced by three main techniques. The one what we call it as a arc discharge technique, the laser ablation technique, or chemical vapor deposition techniques. So mainly we can observe two types of carbon nanotubes, single walled or multi-walled carbon nanotubes, or we may classify it in another way, called it taken as a zigzag tubes, chiral tubes, armchair tubes. Then we'll go to properties of CNT. So almost all CNT are highly electrical conductivity, and they are very strong component, 20 times stronger than and 6 times lighter than steel, hard as diamond, and thermal capacity is twice that pure diamond, and distinct anisotropic thermal behavior along the axis having a high thermal conductivity. So they possess high electrical conductivity as well as a thermal conductivity. So that is, it is hard as well as the thermal capacity is twice that of pure diamond. The charge carrier mobility also high, finds application in transistor, etc. Hold high tensile strength, hold high mechanical strength, thermal stability, enhanced chemical reactivity, high optical transparency, high surface area. So their thermal stability is up to 4000 K. You can observe up to 4000 K and keep high conductivity. So these are the few important properties we observed under carbon nanotube. High electrical conductivity, high thermal conductivity, high mechanical strength, high thermal stability, enhanced chemical reactivity, high optical transparency, and high surface area. The application of this carbon tube mainly observed in energy storage system. They are used as a electrode materials. In particularly in lithium ion battery, it is used as an electrode materials, and it is an energy storage system. In energy storage system, it is mainly used. And even it is used, find application in nano electronics and optics. Even single-walled carbon nanotubes are used in cancer thermotherapy to selectively kill the cancer cells without harming healthy tissues. That is, it is used in the biomedical applications. Then even it is used as an electrical cables that are fabricated with the CNT as they possess high excellent electrical conductivity and thermal resistance. In even it is used in a molecular electronics, CNT based non-volatile RAM, CNT based transistor are used, and the CNT is used in the based on that they are used as a fibers, fabrics, etc. And even CNT based ceramics are used, emitters are used, molecular electronics like CNT based non-volatile RAM, CNT based transistor, energy storage, CNT based fibers, fabrics, etc. are used. And even it is used as a membrane in water treatment. CNT is also being investigated as a support of biocatalyst, and they have an enzyme of immobilization which increase the enzyme stability, control of pore size, multiple activity sites, reduces the mass transfer limitation, etc. It's used as a direct catalyst for some specific reaction such as the produce carbon monoxide and carbon dioxide, free hydrogen, oxidative dehydrogenations of ethyl benzene to styrene. Like in some reaction, it may be used as a catalyst. So these are the important applications find under carbon nanotube. Energy storage system, biomedical applications, CNT based fibers and fabrics, CNT based ceramics, in molecular electronics, and even in water treatment. Next, coming to the next one, nanoscale material, that is graphene. So there's here in the graphite, in the graphene and the carbon nanotube, it is a rolled one, whereas this is a single sheet. See, the layer of one atom thick planar sheet of sp2 bonded carbon atoms densely packed together into a honeycomb shaped crystal lattice, which is observed in the graphene. Here, usually the carbon-carbon bond length, what we observed is 0.142 nanometer. It is the basic structural elements of many other allotropes of carbon, such as graphite, diamond, charcoal, carbon nanotubes, fullerenes. If you observe a carbon nanotubes or fullerene, it is the basic structure. Graphene is the basic structure. It acts as a basic structure in other allotrope form of compound that exist in a two-dimensional planar sheets. Graphene is a flat monolayer of carbon atoms tightly packed into two-dimensional honeycomb lattice. It is a basic building block for graphite materials of all other dimensionalities, including graphite, charcoal, carbon nanotubes, fullerenes, etc. The materials discovered, isolated, and characterized in 2014, and even the structure, if you find, the graphene is technically a non-metal that you know, but it is often referred as a quasi-metal due to its properties like that semiconducting property. Each carbon atom is covalently bonded. Here the carbon atoms are covalently bonded and we observe sp2 hybridization. The free electron exists in a p orbitals, the sites above the plane of the material. Here, the holes also observed in the graphene, so it is act as a good conductor. And it possesses a unique properties like making it is an ideal material for the use in electronic application when compared to other conventional components. Say the property, it is high, it has a high thermal conductivity. So in the structural, this also material of interest due to high electron mobility, and you know holes and electrons are highly mobile and it acts as a highly conducting one. It has a thermal conductivity, even it has a electrical conductivity and the thermal conductivity, good electrical conductivity. The most of the prevalent and the important property of graphene is it acts as an electrical conducting. Graphene does not have any electronic band gap. If you observe in this, there is no electronic band gap, meaning that it can be switched on or off as the valence band or the conduction bands have a small overlap and the electrons act as a massless relativistic particles. Graphene has also great optical property. Along with this, you can observe optical property also. It shows high optical properties, mechanical properties, transparent material, high tensile strength. It is the lightest and thinnest materials which is invented under nanomaterials. It is a high thermal, possesses high thermal conductivity. Okay, so these are the main properties observed under uh, graphenes: high thermal conductivity, high electrical conductivity, high tensile strength, transparent material, lightest material, thinnest material, diamagnetic in nature, optically active component. It is shows high optical properties. Is it's usually a two-dimensional materials, and usually the graphenes are prepared either by chemical vapor deposition method, chemical plasma exfoliation from natural graphite, mechanical cleavage from natural graphite. These are the some methods we adopt in order to manufacture or prepare graphites. Then coming to the application part, the graphite act or it is used in the energy storage system. So it is used in the energy storage system. So energy storage, production, conversions, storage system, particularly hydrogen, energy materials, batteries, supercapacitor, even in a hydrogen storage. So it acts as an energy storage component. It is used as a sensor to monitor even glucose, hemoglobin level, and also to identify harmful gases. So even for sensitizing, it is used act as a mechanical sensor as well as even biological sensor, biosensor, biomedicines, biotherapeutic. So these graphenes are used. Graphenes are used in a biosensor, biomedicines, biotherapeutics, etc. Photovoltaic cell, it is even used in a photovoltaic cell, organic light emitting devices, etc. And even laser materials or photonic sensor, these graphenes are used. And even it is used in the water treatment and for the detection of contamination. So these materials are used in the water treatment. Then drug delivery system, it is used in the like biotherapeutics. Drug delivery systems like nanocapsules are introduced. Liposomes, dendrimers are used. They are acting as a help to find the defects or the complication in the system. And food processing and even in the storage it is used. Even in the packaging materials, oxidative resistant packaging and wiring materials. As a wiring materials, it is used. It is used as an electronic emission display device. It increases the efficiency of the battery and to improve the charge and discharge cycle rate. It is increase the strength of composite material. If you mix with the composite material, usually it increases the strength. Act as a catalytic supporter in many chemical reaction. Even it is used in a data storage system, construction health, and construction related work. Nanomolecular structure for waterproof asphalt or concrete is used. Health monitoring system. In health monitoring system also graphenes are used like nanotubes, nanoparticles for glucose, carbon dioxide, cholesterol sensor. For that monitoring it is used. And vectors and pest detection and control, these nanomaterials are graphene materials are used. These are some important application observed under graphenes in energy system, biological system, photonics like laser material, photonic sensors, then sensing systems, materials like packaging materials, and even it used in the electronic device. It is used as a sensor to monitor glucose, hemoglobin level, and also to identify harmful gases. It is used to increase the efficiency of the battery, to improve the charge and discharge cycle. Emission display, electronic emission display device, increase the strength of composite material, and also used as a catalytic support.